Hello everyone. Today, we're diving into the fascinating world of cryptocurrency and figuring out how it actually works. Now, in our last lesson, we talked about why cryptocurrency was created and the solutions it offers to the world. But understanding the why is just the first step. Today, we're going to explore the how. To make everything crystal clear, I'm breaking down today's lesson into three main sections. First up, we have introduction to blockchain technology. Cryptocurrency relies heavily on this technology, so understanding it is absolutely crucial. We'll explore what blockchain is and why it's the backbone of all cryptocurrencies. Next, we'll get into crypto miners and the mining process. We'll break down who these miners are and what exactly they do to keep the cryptocurrency world running smoothly. Finally, we'll dive into the concepts of public and private keys. These are the tools that make cryptocurrency transactions secure and trustworthy. By the end of today's lesson, you'll have a solid technical understanding of how cryptocurrency works. So, let's jump right in and get started. Alright, let's start with the basics of blockchain. Now, imagine a blockchain as a digital ledger, or more simply, like a giant book where every transaction ever made is recorded. But here's the cool part. This book is not kept in just one place. Instead, it's shared across a whole network of computers, and everyone has the same copy of it. So, whenever someone makes a transaction, it gets written into this book, and every single copy of the book updates instantly. This makes blockchain super secure and transparent because no single person controls it, and everyone can see what's written in it. It's like having a digital notary that records everything but can never be altered or erased. Alright, now let's dive a bit deeper into how this blockchain technology actually works. Imagine we have four people, A, B, C, and D, let's say, who wants to send one Bitcoin to B. Now, I'm using Bitcoin as an example because it's the most well-known cryptocurrency, but don't worry, we'll cover everything about Bitcoin in future lessons. Okay, let's go back to our example. A is sending one Bitcoin to B. C is sending 2 Bitcoins to D. B is sending 4 Bitcoins to C. And C is sending 2 Bitcoins to A. As you can see, there are quite a few transactions happening here. Now, if we take all these transaction records and group them together, we can call this group a block. This block is a crucial part of blockchain technology because it's where all these transactions are recorded. Now, here's the interesting part. Once a block is created, it gets linked to the block that came before it, like adding a new link to a chain. So, as more transactions happen, new blocks are created and connected to the previous ones, forming a continuous chain of blocks. And that's how we get the name blockchain. It's a chain made up of linked blocks, each one securely holding a record of transactions. Alright, now that you have a basic understanding of how blockchain works, let's take a closer look at the key components of a block. Before we dive deeper into blockchain technology, it's essential to understand what makes up a block. First, let's focus on transactions. We already know that transaction records are a crucial part of a block. Each block contains its own set of transaction records, which are essentially the details of who sent what to whom. Great. Now let's move on to the second key component of a block, the hash code. Every block has a hash code, which acts like a unique fingerprint for that block. This hash code is generated using the transaction details within the block. It's created through a special process called cryptographic hashing. Essentially, the hash code is produced by running the block's information through a complex mathematical function. This function transforms the information into a unique string of characters. This ensures that no two blocks have the same hash code, making each block easily identifiable and secure. Alright, let's move on to the third component, the previous block hash code. Each block not only has its own hash code, but also includes the hash code of the previous block. You'll get a clearer understanding of this previous block hash code in the next part, which I'll discuss shortly. Alright, now you know that a block has three major components. They are transaction records, the block's hash code, and the previous block's hash code. Great. Now, let's see how these blocks come together to build the entire blockchain. Suppose we have a block, and we'll call it block X. Block X has its own set of transactions, so let's refer to them as the transactions of X. It also has its own unique hash code, which we'll call hash X. Alright, so after block X is created, another block is generated, which we will call block Y. Just like block X, block Y has its own transactions. Let's call them the transactions of Y. And of course, block Y also has its own unique hash code, which we will call hash Y. Now, let me ask you a question. What is the previous block hash code of block Y? Yes, you got it. Hash X is the previous block hash code of block Y. Now, this is pretty cool. When block Y is generated, it needs to connect to the previously generated block X. So how does that happen? It happens through the hash code of block X. That's why block Y includes the previous block's hash code hash X, so it can securely link back to block X. This connection ensures that all the blocks are properly chained together, forming a continuous, secure blockchain. So after block Y is created, another block is generated, which we'll call block Z. Just like before, we can refer to its transactions as the transactions of Z, and its hash code as hash Z. And as you might guess, hash Y will be the previous block hash code for block Z. So block Z follows the same method we just discussed for connecting to the blockchain. Just like block Y, it connects to the previous block using its hash code, ensuring that the chain continues securely and seamlessly. Now, I know you might have a question. What is the previous block hash code of block X? Well, block X is actually the very first block in this blockchain, since there was no block before it. It doesn't have a previous block hash code. The cool thing is, we call this first block as the Genesis block. Additionally, someone might ask, how many transactions are there per block? Well, the answer actually depends on several factors. For example, in the Bitcoin blockchain, a block typically contains about 1,500 transaction records. However, we cannot say exactly 1,500 transactions per block. The actual number depends on various factors, such as the size of each transaction and the overall block size. Alright, now that you have a clear understanding of how each block connects to the previous one, you can see how these blocks link together like a chain. That's why we call it a blockchain. A blockchain is made up of many blocks, and each block contains its own set of records. Now, here's something really important. Blockchain is immutable. That means once a block is added to the chain, it can't be changed or tampered with. Remember when we talked about hash codes? Each block has its own unique hash code, created based on its transaction data. If someone tried to change even a tiny detail in a block, the hash code would completely change. But here's the catch. Each block is connected to the previous one through its hash code. So if the hash code changes, it would break the connection to the next block, and the whole chain would fall apart. This is what makes blockchains so secure. Once a block is in the chain, its information is locked in place, and no one can go back and alter it. That's why blockchain is trusted. It keeps the data safe and unchangeable. Alright? Do you remember the four people, A, B, C, and D, we talked about earlier? Well, in the world of blockchain, we can actually call them blockchain nodes. Each of these nodes is a participant in the blockchain network. Alright, now you have a solid understanding of blockchain technology and how it actually works. You have seen how blocks are created, linked together, and secured, and how nodes play a role in this process. So, let's move on to our next section. In this section, let's talk about cryptocurrency miners and the mining process. We already know that after a new block is generated, it connects to the previously created block. But who actually handles this process? Well, that's where the cryptocurrency miner comes in. The person who does this task is called a crypto miner. And the entire process of connecting these blocks is known as crypto mining. Alright, let's take a closer look at the major task of a crypto miner. So, what does a crypto miner actually do? First, the miner has to validate all the transactions within a block to make sure they're legitimate. Then comes the tricky part. We know each block has its own unique hash code. It's the miner's job to solve complex mathematical problems to identify this hash code. Once the miner successfully solves these problems and finds the correct hash code, they can then add the block to the blockchain. And as you already know, this is how blocks are securely linked together in the blockchain. So, do you think this mining process is easy? Actually, it is not. Mining requires a lot of computational power to solve those complex mathematical problems. But there is a reward for all this hard work. Miners are rewarded with cryptocurrency for successfully adding a block to the blockchain. Okay, now that you have a clear understanding of the crypto mining process, let's move on to our final section, public and private keys. Alright, let's use an example to make this clear. Think about how you use your bank account for fiat money, which is the everyday money we use. In lesson 1, I went into detail about fiat money, so feel free to check that out if you are interested. Now, imagine you have a bank app on your phone. To get into this app, you need to enter your email address or username and your password. This helps you access your account. If your friend wants to send you money, they need your account number. So, you need your email or username and password to log in and use your bank app, and you need your account number to receive money. It works a bit similarly in cryptocurrency. To access your cryptocurrency wallet, you use something called a private key. This is like your password, and when you want to receive cryptocurrency from someone else, you give them your public key. Think of the public key like your account number. It's what others need to send you crypto. I know you might not have much knowledge about cryptocurrency wallets yet, but don't worry. I will cover everything you need to know about crypto wallets in the next videos. However, I think you have got a clear understanding of the private and public keys concept now. In this image, you can see an example of what these keys actually look like. Okay, cool. That's it for today's lesson. By now, you should have a clear understanding of the major components of a block, how blocks connect to form a blockchain, what a crypto miner does in this process, and the concept of private and public keys. In the next lesson, we will dive into even more interesting topics. This beginner-friendly video series is designed to give you a solid and massive understanding of cryptocurrency. Thank you for watching. Please give it a thumbs up and leave a comment below. Don't forget to subscribe to CryptoCookie.